You've heard of the Great Flood, but what if, instead of water, every ocean, lake, and river on Earth was suddenly, instantly replaced with honey? It's a ridiculous thought, I grant you. A children's storybook apocalypse. The end of days sponsored by a breakfast cereal mascot. But if we follow the science, this sweet, sticky scenario cascades into one of the most bizarre and terrifying extinction events imaginable. The universe, after all, doesn't care if its tools of destruction are asteroids or apiaries. The very first change, in the first fraction of a second, is a question of weight and character. Honey is, on average, about 1/4 times denser than water. So, in that silent, instantaneous swap, we've just added about 40% more mass to all the world's oceans. That's an extra 548 quadrillion metric tons of stuff. The planet itself would barely notice, its rotation and orbit unchanged. But everything on the planet would notice, especially gravity. See, water is wonderfully fluid. It fills its basins neatly. Honey is a non-Newtonian fluid, thick and profoundly lazy. It possesses something called viscosity, a resistance to flow. It's about 10,000 times more viscous than water. This is the difference between pouring yourself a glass of water and trying to pour cold molasses into that same glass. One is obliging, the other is a geological event in miniature. So, in the instant of the swap, the honey doesn't sit neatly where the oceans were. The Pacific, the Atlantic, the Indian, they are no longer oceans. They are colossal, continent-sized blobs of goo. And gravity, the universe's ultimate party pooper, immediately gets to work. These honey blobs are gravitationally unstable. They are piled too high. They need to flatten out. This begins the Great Slump. It wouldn't be a wave in the way we understand it, not a cresting, crashing tsunami of water. This would be a wall, a slow-motion, golden amber glacier of absolute annihilation. Let's check in on our designated observer for this catastrophe, a geophysicist named Dr. Alara Vance, who happens to be working at a high-altitude observatory in the Swiss Alps. One moment, she's sipping her morning tea and looking out at the distant, shimmering blue of the Mediterranean. The next, it's been replaced by a vast, placid amber mirror. For the first few minutes, the world is eerily silent. Marine life, of course, has already had a very, very bad day. Any creature with gills is instantly entombed. A blue whale, one moment gliding through the abyss, is now suspended in a medium it cannot process. Its immense weight no longer supported by buoyancy in the same way. Every fish, every shark, every microscopic plankton is flash preserved. The oceans have become the largest amber fossil on record. Marine biology, as a field of study, would be retired. But Alara, high in her mountain lab, wouldn't know that yet. What she would see through her telescope is the edge of the honey Mediterranean beginning to move. Not fast, but with an inevitability that would curdle the blood. This isn't a wave you can outrun. It's a geological process you can merely witness. Imagine a wave hundreds of meters high moving at the speed of a brisk walk. It doesn't crash, it arrives, it pours, it engulfs. It's not made of water, which might recede. It's made of a substance whose entire purpose is to stick to things. The city of Rome would not be washed away. It would be candied. The Colosseum filled to the brim, the Vatican submerged, all of it sealed in a perfect eternal tomb of fructose and glucose. The wave would flow up valleys, fill canyons, and bury everything under a suffocating, sticky blanket. It carries the momentum of 1 billion tons of sugar, and there is nothing, absolutely nothing, that can stop it. Global shipping, by the way, just became a lot more complicated. And it gets worse. By hour 3, the atmospheric consequences are kicking in. The single most important process for our climate is the water cycle. Evaporation from the oceans seeds clouds, which create rain, which drives weather systems and waters the continents. Honey, however, does not evaporate in any meaningful way. It's hygroscopic, meaning it actually pulls moisture out of the air. So the sky becomes terrifyingly clear, and it stays that way forever. No more clouds, no more rain, no more snow, no more of that annoying misty drizzle that fogs up your glasses but isn't committed enough to be a proper downpour. The planet's weather engine has ceased. The Amazon rainforest, which generates much of its own rain, would last a little longer, but without the massive influx of moisture from the Atlantic, it too is doomed. It would begin to wither and die. All the world's rivers, deprived of their source, would run dry in a matter of weeks, their beds becoming dusty canyons. Dr. Alara Vance, safe for now in her alpine fortress, would watch the world turn brown. The lush green valleys below would fade to a sickly yellow, then a desiccated tan. The Great Slump of honey would have stopped its advance by now, burying all coastal civilizations and low-lying areas, reaching a new, sludgy sea level slightly higher than before. The world map would have to be redrawn by a very depressed cartographer. Day 10. The Great Thirst begins. Every land animal and plant on Earth is now facing a terminal dehydration crisis. There is no more fresh water, none. Humanity's only sources would be the ice caps of Greenland and Antarctica, and the glaciers nestled high in the mountains. For Alara and the few other mountain communities, survival becomes a frantic race to melt glacial ice. But this is a finite resource, a tiny puddle in a world-spanning desert. The air itself would become painfully dry. Static electricity would be a constant crackling menace. Your lips would chap, your skin would crack, and every breath would feel like inhaling dust. The temperature swings would become brutal. Without cloud cover to trap heat, deserts would be scorching by day and plunge below freezing at night. And then there's the smell. At first, it might be pleasant, a faint, sweet floral scent carried on the wind. But as the trillions upon trillions of dead things, from plankton to people, begin to decompose anaerobically beneath the honey, the smell would change. It would become a sickeningly sweet, cloying odor of decay and fermentation. The world would smell like a forgotten fruit bowl in the summer sun on a planetary scale. Year 1. The survivors, if any exist, are confined to high-altitude islands like the Alps, the Himalayas, the Andes, and the Rockies. They are prisoners in their mountain fortresses, looking out over a silent golden world. Agriculture is nearly impossible. The soil is turning to dust. The only remaining life would be the hardiest lichens, mosses, and perhaps some incredibly stubborn insects. A lone, confused bee might buzz past Alara's window, the last of its kind in a world drowned by its own life's work. A cosmic irony too cruel to be funny. Almost. Alara's primary scientific obsession would shift. She's no longer a geophysicist. She's a honeyologist. She would study the strange new properties of this golden sea. She'd note that in the crushing pressures of the deepest parts of the ocean, like the Marianas Trench, the honey might behave in ways we can't predict. Under 1,100 atmospheres of pressure, the sugars could be forced into crystalline structures, creating vast deposits of rock-hard sugar at the bottom of the abyss. Planetary geologists, assuming they weren't buried under a fruit-based mountain, would have a field day. Year 100. Humanity is likely extinct. A few isolated enclaves might have held on for a generation or two, but without a functioning biosphere, without a water cycle, our reign is over. The Great Honey Sea would have settled. Its surface, exposed to the dry air and relentless sun, would form a thick, hard crust, like the top of a creme brulee. Beneath this crust, the world would be in stasis. The buried cities, the fossilized whales, the entombed forests, all perfectly preserved. And what of the honey itself? Would it ferment into a planet-sized batch of mead? Unlikely. Fermentation requires yeast and, crucially, a certain water content. Honey is naturally antimicrobial precisely because it has so little available water. Without rain to dilute the surface, the honey oceans would remain inert, a sterile, sugary preservative. Our world, once a dynamic, chaotic, water-sloshed marble of blue and green, would become a quiet, static artifact. A golden bauble in the solar system. An alien astronomer charting our corner of the galaxy would see Earth's light signature change. The spectral analysis would be baffling. An atmosphere almost devoid of water vapor, and a surface that reflects light in the warm, golden hues of complex sugars. They would be utterly perplexed. Looking out from her lab for the last time, an elderly Alara Vance might have one final thought. She survived the initial wave. She outlasted the Great Thirst. She watched the world she knew turn into a silent, sweet graveyard. But her most persistent, nagging thought, the one that stuck with her through the entire apocalypse, would be an unexpectedly mundane one. Back on that first day, as the initial shock wore off, a tiny splatter of the advancing honey had landed on her favorite hiking boots, and she knew with absolute certainty that she would never, ever get them properly clean. So, could we survive a planet-wide flood of honey? Not a chance. Our world isn't just supported by water, it is water. Water is the restless engine of our planet, the solvent for life, the architect of our climate. Honey is a wonderful treat on toast, but as a planetary operating system, it's a catastrophic failure. It reveals a profound truth. The substance that makes our world beautiful and alive is not special because it's rare in the cosmos, but because of its exquisitely simple and relentlessly active nature. We live, it turns out, on a planet defined not by spectacular sweetness, but by the beautifully boring, life-giving rhythm of a simple drop of water.